Welcome back. In the previous episodes, we explored METARs and their role in flight safety. Now, in this final part of our meta series, we're going to dive into the Meteorological Terminal Forecast, TAF. A TAF provides weather forecasts for aviation operations at airports and is essential for pilots during flight planning and landing. Let's begin by understanding what a TAF is. A TAF is a forecast that covers specific airports and gives details about expected weather conditions for a 24 to 30-hour period, with updates every 6 hours. It focuses on winds, visibility, cloud cover, and precipitation that will affect takeoff, en route, and landing operations. A typical TAF might look like this. Let's break it down. EGLL is the airport identifier, London Heathrow. 131720Z is the time the TAF was issued, 13th day, 1720 UTC. 1318-1424 is the forecast period, from 6 p.m. Universal Time coordinated on the 13th to 2400 hours UTC on the 14th. 28012G18 KT is the wind, from 280 degrees at 12 knots, gusting to 18 knots. 10 SM means visibility is 10 statute miles. SCT 020 BKN 080 describes the clouds, scattered clouds at 2000 feet, broken clouds at 8000 feet. TAFs are used primarily for flight operations. Pilots need them to prepare for arrival conditions at their destination. For example, if the TAF predicts low visibility or low cloud bases, pilots will know they might need to use instrument flight rules, IFR, or prepare for an alternate airport. One important feature of TAFs is that they provide both general weather trends and specific weather conditions expected at an airport during the forecast period. Pilots will check the TAF for expected changes in wind direction and speed, cloud cover, and precipitation that could affect landing decisions. For example, let's say you're flying into Paris Charles de Gaulle and the TAF shows winds gusting to 30 knots. If the runway you're planning to land on is aligned with the wind, this might not be a problem. But if you have a crosswind approach, gusty winds could make landing difficult. Knowing this in advance allows you to adjust your approach and landing techniques. Another part of the TAF is the trend forecast. Sometimes, amendments are issued for weather changes expected to occur during the forecast period. For instance, a TAF might indicate that clouds will move in after a certain time, or visibility will be reduced due to a storm front. Pilots must remain aware of these updates to ensure smooth operations. Now let's look at TAF limitations. While METARs give you real-time weather observations, TAFs provide forecasts, which have a margin of error. The further you are from the forecasted time, the less accurate the forecast will be. For example, a TAF for the next 24 hours is generally reliable, but forecasts beyond that might be subject to rapid weather changes. For this reason, pilots must also rely on real-time updates from ATIS, Automatic Terminal Information Service, ATC, or weather radars. This helps verify the forecast and adjusts the flight plan if needed. TAFs are divided into sections for specific times. A forecast could include multiple blocks, such as tempo, temporary changes expected within the forecast, probability of certain weather conditions, and sometimes FM, from, when a significant change is expected. For example, you might see FM 121800 in a TAF, indicating a significant weather change expected to start at 6 p.m. Universal Time coordinated on the 12th. This section tells pilots to prepare for a shift in wind direction, changing visibility, or cloud formation. One of the most critical elements of a TAF is visibility. Pilots need to know how far they can see in all weather conditions. A TAF will give visibility information in either statute miles or meters, depending on the region. For example, 10 SM means 10 statute miles of visibility. It's essential for pilots to check these values, especially when landing in areas prone to fog or low cloud. Now, let's take a quick look at TAF interpretation during approach. For example, if the TAF shows clouds below 1,000 feet, it may signal the need for an ILS, Instrument Landing System, approach. Alternatively, if visibility is reported as less than 3 statute miles, a visual approach will not be safe. The TAF also provides information about winds during landing. If the forecast shows crosswinds, pilots must be ready to adjust their landing technique. Crosswinds can make landings more difficult, so it's important to know the maximum crosswind limits for the aircraft you're flying. Let's take a flight from Los Angeles to San Francisco. The TAF shows good visibility and clear skies at the departure point. However, upon arrival, the TAF at San Francisco predicts clouds and turbulent winds around the time of your arrival. Thanks to the TAF, you can prepare for an alternate approach or even a diversion to a nearby airport like Oakland. Let's not forget the role of TAFs in general flight planning. During long-haul flights, pilots rely on TAFs to stay updated on weather changes. For example, flying from New York to London, a TAF will show if low-pressure systems or fronts might develop along your route. With this information, you can adjust your altitude and course to avoid turbulent conditions. In the next episode, we'll dive into TAFs Part 2, where we'll go deeper into forecasting techniques, how to interpret TAF amendments, and best practices for pre-flight briefings. See you in Meteorology number 53, TAFs, Terminal Aerodrome Forecasts.